Welcome once again to today's event, CPDLC, Path to Compliance. Our presenters today are Chris Medlock and Julkie Lauren. Chris, you now have the floor.
All right, thank you very much, Nicole. As Nicole said, my name is Chris Medlock. I'm the Product Manager of Aircraft Systems Engineering and Certification here at EMTEQ. I'm joined by Julkie Lauren, who's our Director of Technical Services, and one of our staff FAA VDRs to support the presentation. What we're going to provide today is an overview of CPDLC, what it is, who requires it, where it's required, some of the systems that form the CPDLC system as a whole, what some of those equipment options are, and what the paths to compliance can be in terms of supplemental type certification, which is a service that EMTEQ offers. So with that, we'll go ahead and get started with an overview of what CPDLC is. So CPDLC is an acronym for Controller Pilot Datalink Communications, which is essentially an air-ground communication service using Datalink. In other words, it's text-based communications between the cockpit and air traffic control as opposed to voice communications, which are typical. This is meant to supplement the voice communications that have been existing for some time. Basically, anything that's provided currently via voice communications can be provided through text. So this would include any type of air traffic control clearances, any pilot requests, or any position report. CPDLC was developed in Europe. It actually started a little over a decade ago, pioneered by the Maastricht Upper Area Control Center. Since then, it's been refined and developed for what it is today, which has led to the development of the mandates that are coming up in Europe. And essentially, CPDLC uses an ACARS system for the VHF Datalink radio to provide those text messages for those communications. CPDLC is actually the reference to the 160 predefined text messages that are located in the ACARS software. Those are standard text messages for altitude changes, for speed changes, heading changes, things of that nature that are already in the software that's provided with the ACARS system. CPDLC is a key element of the Eurocontrol EASA STC, as well as the FANS 1A, the Airbus and Boeing developments for the future air navigation systems. And they use a means of whitelist to track which aircraft are compliant to the airspace. In Europe currently, there's several whitelists that have been developed for aircraft that meet the current FANS and CPDLC requirements so that controllers know which aircraft are aptly equipped and can benefit from using the CPDLC operation. As I mentioned, Europe, as many of you probably already know, there's a mandate upcoming in Europe in February 2015, which is the current date, for all aircraft flying above flight level 285. Right now, it's already been mandated for a few years for forward-fit aircraft, so any new build aircraft coming from Airbus, Boeing, or any of the other manufacturers. But this mandate applies to retrofit, so any aircraft operating within Eurocontrol airspace. And that's for equipage of CPDLC for any aircraft flying at that altitude or above. There are some exemptions that are available for older airframes, which has been a little bit of a topic of debate. It continues to change. However, it seems that some of the older airframe types that are out of production or they're not foreseen to be operational for too much longer, the near term, that Eurocontrol is granting exemptions for those aircraft types and not have to equip and fly with CPDLC systems. The air navigation service providers throughout Europe are on a varied implementation schedule. As we'll show you in the next couple slides, or next few slides, there's been intermittent implementation of the CPDLC architecture. So not all areas have service yet. This is the current map, which shows where full implementation is in the dark green, partial implementation in the lighter green, and no plan in the red areas. So the dark green areas right now currently have a full-up CPDLC system on the ground side to support CPDLC operations in the air. So they're actively using the text-based Datalink communications with aircraft flying through that airspace right now. The next few years, there's going to be more areas, obviously to the north and to the west, that are fully equipped for CPDLC operations, and then even more so after that. And continuing on through the latter part of the decade, there's going to be more implementation throughout some of those areas that are not currently shaded dark green. But this gives you an idea of what through the end of next year, those areas that are going to be fully equipped to handle CPDLC operations. Additionally, in North America, the FAA has a Datacom initiative, which is similar to the Eurocontrol initiative. However, the Datacom initiative is part of the next-gen systems that the FAA has been working to develop and implement. Right now, there's no mandate that's known or has been communicated by the FAA. There's no plan in place to make that a mandate. So right now, it's optional equipage. And the National Airspace Air Traffic Control System won't be equipped until probably the later part of the decade. It's going to start next year and continue on through the end of the decade. Additionally, the North Atlantic Track System, which is where some of the FANS and CPDLC trials took place, right now, aircraft equipped with CPDLC have the benefit of using the innermost tracks between flight level 360 and flight level 390. The benefit of this is these are typically the shortest distances between North America and Europe on the North Atlantic Track System, and this obviously provides the best winds, the best fuel burn, things like that. So it's a means of cost saving. Going through the later part of the decade, additional areas of the North Atlantic Track System, altitudes, and the different north and south tracks will also be implemented to be able to support CPDLC and FANS operation. And as I mentioned before, CPDLC is one of the components of a FANS upgrade with some other systems and ADS contract, which we won't get into today. There are several benefits to equipping for CPDLC, and there's a strong motive from the air navigation service providers. Really what it comes down to is air traffic management, a means of sticking more aircraft in the same airspace. It allows reduced lateral and longitudinal separation in conjunction with ADS-B, which is also due to be implemented later in this decade. For aircraft that are equipped with CPDLC, what it will allow you to do is to pick up preferential routing. Aircraft that are equipped will be able to fly on certain routes that aircraft that are not equipped will not be able to. Reason being is obviously aircraft that are equipped with CPDLC systems can benefit from the text-based communications, which we'll go into in the next few slides here. Essentially, it creates a faster and safer means of clearance delivery and maintaining positive control on the aircraft. Aircraft that are not equipped will essentially see limited operations in some of those areas moving forward. It reduces cockpit and control tower workload through automation. Essentially, it's minimizing the usage of voice, which can often lead to missed clearances or miscommunications or unreadable communications. If you have a text-based message in the cockpit, it's something that can be easily read back and easily understood. It's not something that is going to have to be communicated several times between the cockpit and the control tower. It's an alternate communications channel with air traffic control. So it's not intended to replace voice communications. It's intended to supplement. So the voice communications channels that have been used will be preserved as a backup for the long term. And as I mentioned, it reduces delays through the increased system capacity in that the clearance deliveries are faster, so you're getting faster action from the aircraft to get to assigned altitudes and speeds and headings and things of that nature. So it gives more control to the air traffic control system. And now what we'll do is we'll kind of run through what a CPDLC system really consists of. There are several systems in the aircraft that come together to form the CPDLC compliant system. What most people think of course, is really the brain is the ACARS, the Communication Management Unit, so the Aircraft Communications Addressing and Reporting System. That not all aircraft have, but several do. Typically used for airline operational control communications. Its transitioning as being the baseline for the air traffic communications in the context of CPDLC and fans. And really what that requires is an ARINC 758 Communications Management Unit with a CPDLC and VDL Mode 2 or VHF Datalink Mode 2 capable software set. So this is the software set that contains the block of the standardized CPDLC text messages with those clearances and requests for altitudes, headings, position reports, things of that nature. Additionally, with an ACARS system, you have to have a VHF communications transceiver. For CPDLC being data or text-based, you have to have a VHF Datalink Mode 2 communications transceiver, and there's several options on the market available for that. Additionally, you need to have a control display unit in the cockpit so that the messages can be received and read by the crew, and responses can be sent back to the air traffic control unit. There's several OEM service bulletin upgrades available for MCDUs, and additionally what we'll show you is that there's also some smaller, more economical units that can be used as well to serve the same purpose. Another one of the large components that was mandated specifically by EASA and Eurocontrol for the CPDLC implementation was Datalink Recording. Datalink Recording is essentially a means of recording all of those text message clearances between the cockpit and air traffic control in place of what would typically be recorded for voice on a cockpit voice recorder. And there's two methods that are acceptable in different areas of the world. Right now in Europe, you can use either a cockpit data printer or you can use a cockpit voice recorder. There's some updated cockpit voice recorders which are capable of recording the data link communications, so not all cockpit voice recorders are inherently capable. And right now, as I said, it's an option in Europe that you can use a cockpit data printer. The CVRs are not mandated. However, in the U.S., with the FAA regulations, it is mandatory to use a cockpit voice recorder to meet the requirements of Advisory Circular 20-140B. So with that, you have to have a UTC Time Stamp source. So this provides a timestamp on all of the messages that are being recorded so that if the need is there to go back and look at what communications were exchanged between the cockpit and air traffic control, they know exactly what times and those communications were sent, received, and responded to. And there's several means of providing that UTC timestamp. There's multi-mode receivers, which most newer aircraft have, not all aircraft do. There's a GPS sensor, which is a popular option if the aircraft does not have MMRs or if the operator may be looking for a more simple integration. And then there's the possibility of using the existing enhanced ground proximity warning system if it's equipped with a Mercury card GPS, an internal GPS. So those can provide a UTC timestamp source for those recorded messages. Also in the cockpit, you have to have a means of enunciating to the crew that a message has been sent to the aircraft. There's two different types of enunciation that are required. So essentially, if the operator is using the CPDL system for both its ACARS or AOT functionality and for the air traffic control, the data link functionality, you can either have external enunciators, typically LED enunciators installed in the instrument panel adjacent to most of the cockpit displays and in plain view of both crew members that will tell them if they receive either an ACARS message or an air traffic control message, or there are service bulletins that can be provided for the ICAS to display those same messages. Additionally, it needs to be made known to the crew when they have a failure of the Datalink Recording system. And the last component is the Mode S transponders. And there's some other interfaces which we'll show you here in a few minutes that are required for the system. So this is kind of a sample CPDLC architecture. It's not comprehensive by any means, and it's just showing a sample setup. But what we're showing is that communications management unit in the center, an airing 758 unit. Moving forward, there'll be some options for that to use 724B as well. It's got an aircraft personality module hooked to it, which most of the newer units do use. And then you'll see the interfaces that we discussed, the MCDUs to the MMRs or an alternative system, to the cockpit voice recorder, the data radio, and of course the audio and display controls in the cockpit. One thing to note is that implementation of a CPDL system does vary per avionics suite, architecture, and by aircraft type. So because of the number of aircraft configurations that are out there between models and series, even consecutive serial numbers of the same aircraft type, there's a lot of dependencies and a lot of variables that go into determining what system is best fitted to the aircraft. But what we wanted to do was to give you a sample of what some of those systems will be. And this chart just kind of shows what some of those systems are. I know it's very small print, but what we wanted to show you is that on the left-hand side, we start out with the airing 758 or 724B ACARs. There's traditional ACARS systems when you think of your Rockwell Collins CMU 900 ACARs or your Honeywell Mark II ACARs. They require an external aircraft personality module, an MCDU, a separate VHF communication system, and then there's integrated ACARS system like the Spectralux D-Link Plus with CPDLC and the Universal Unilink ACARs, which actually both have an integrated VHF3 communications transceiver in the unit. And the Spectralux D-Link Plus is essentially an all-in-one box. It's an MCDU with an integrated communications management unit. So it's a display unit with the internal communications management unit as well as the VHF3 transceiver all in one box. Additionally, if there's external VHF communication systems required, there's compliance systems from Rockwell Collins and Honeywell, among other manufacturers. We show the options there for Datalink Recording as well. The cockpit voice recorders with the Honeywell HFR 5B and an L3 FA2100, or the cockpit data printer. One of the more popular printers is the Honeywell PTA 45. There's also systems from Matsushita and other manufacturers as well. We show the options for the UTC Time Stamp source, the GPS sensor, the multi-mode receiver, or the eGPWS with a Mercury card. There's several independent sensors which can be used. Most of the MMRs are typically service bulletin upgrades or come from the manufacturer or the aircraft when it's delivered, it's already installed. The cockpit Annunciation, we mentioned either using an ICAS software service bulletin or the external LED annunciators. And what we're showing on the other side is just some of the systems that the CPDLC system requires. So starting out with the ACARS, as I mentioned, 758 is the current requirement. In the future, there may be availability to use a 724B system, but we don't. That's currently not yet approved. It does require the applicable and capable software set, so it's got to have software that's specifically intended for CPDLC and data link recording operations. So that's something that must be verified with the manufacturer when placing an order for the ACARS system to ensure the compliant and correct software is provided. And as I mentioned before, too, there's several factors that go into deciding which ACARS system is best for your aircraft. The existing avionics architecture in the airplane for required interfaces and what really the operational goals of the operator for the air carrier are. Different systems offer different levels of options. The VHF3 system must be a VHF data radio, airing 750. For fans installations, these are typically data only. However, if you're using them for CPDLC, there is the ability to use that third VHF system in either a voice mode or a data mode. So there's switching capability there, which essentially just adds some operational flexibility for the air carrier in that they may be able to dispatch if one of the number 1 or 2 VHF radios goes down. They can't have voice data switching capability, though, that may impact some of the other equipment that's already installed in the aircraft. Datalink recording we've discussed already a little bit at length, but for the cockpit voice recorder, really the Datalink recording enunciations are required. The fault indications are required just to let the aircrew know that when the Datalink recording fails, essentially they have to stop operating using Datalink and they must switch to voice communication. And as we mentioned before, the cockpit data printer is minimum equipage for EASA. So a cockpit voice recorder is not yet mandated by EASA. However, there may be a change to those regulations moving forward. The UTC Time Stamp source, of course, there's multiple options. Most aircraft, or I believe all aircraft, should be equipped with an HBWS or a similar system, a SAW system. If that system would have an internal GPS, specifically the Honeywell HBWS with a Mercury card, that is an option that can be used. And if the aircraft does not have multi-mode receivers or some other type of position source, an independent GPS sensor can be installed. And those are typically low-cost options. And some of the options actually offer paths for upgrade for future flexibility for things like performance-based navigation and other mandates that are coming on down the line that require a similar interface. The message enunciation, we talked about the ICAS or DEU message enunciation. This is something that's required to get from the manufacturer, the aircraft manufacturer. Reason being is that it's typically a proprietary software change that third parties cannot typically provide for your larger air transport category aircraft with some of the avionics architectures that they have installed. The benefit of using this is that there are no physical modifications required in the flight deck since the software changed to existing or upgraded equipment. There is associated delta in cost and schedule to obtain those service bulletins, however, which is why some customers prefer to go with the external LED enunciators. Those require structural and electrical modifications in the flight deck. However, they're a fraction of the cost of the integrated ICAS or DEU upgrade, and they do provide a much shorter schedule, much shorter lead time for implementation. As far as Datalink fail enunciation and then the ACARS and ATC message enunciation is concerned, specifically the ACARS, if the customer is not using or the operator is not using the system for AOC communications as well, they don't really have to. So CPDLC typically uses an ACARS type system, but it doesn't necessarily have to be used for ACARS. It can be used for ATN and air traffic communications only. But obviously that's very limiting in the fact that it can't be used for airline operational control activities. Now we're going to go into some of the routes to certification. There's really two main paths right now. There's supplemental type certificates, which are based on existing type certificates that a lot of third parties and some manufacturers offer to customers. And there's also the OEM service bulletin from the aircraft manufacturers. The big differences between STCs and service bulletins really boil down to cost, schedule, and flexibility. Essentially, the STCs provide a solution, a comparable solution at a lower cost on a much shorter schedule and with very, very increased flexibility. EMTEQ holds over around 200 STCs, including several for ACARS and SATCOM and some of the CPDLC type systems. We do these with the ability to meet the specific operator's requirements, in that we're not designing something for essentially every aircraft out there. We take other operators' aircraft into account so that the same installations can be applied later, but we do give the customer who's doing the STC with us the options and the flexibility to make changes to the overall system design to meet their needs and their schedule and their cost targets that they have for the implementation program. We can also, obviously, we have variability in our schedules to be able to meet the customer's downtimes when they have an aircraft coming down for maintenance or they have an aircraft that's going to be down for a survey. We can obviously work around to make those opportunities come to fruition. Typically with your service bulletins, they're much, much higher cost. Typically there are quite a bit longer lead time. And I think really what the benefit is of an STC is also getting the customer or the operator in the loop from the beginning and letting them know exactly what they're going to be getting and allowing them to be a stakeholder in making some of those decisions on how the system's going to be integrated into the aircraft. So really with the supplemental type certificate, one of the first steps that's determined is what certification requirements there are. So where the customer is operating the aircraft, where the aircraft is registered, whether it needs an FAA STC or an EASA STC or both, and possibly a validation in a foreign country. From there, what we typically do is we request aircraft data from the customer for their fleet, and we develop a design data package. So we take the baseline aircraft configuration, and we take the equipment data, so the technical data on some of the systems that we discussed, and for the various components, the ACARS, the VHF, the CVR or data printer, and then the position source, and we integrate that together and create a design data package that shows the customer how to install the system in the airplane. We also develop an installation kit, which consists of some of the provisions that you see there, some of the all required wiring harnesses, coax cable assemblies, any mounting trays for the equipment. Some CMU mounting trays and VHF mounting trays are shown on the left, as well as the structural components that would be required to mount an antenna or any other mechanical items in the aircraft. Once that's provided, that's shipped to the customer, it's installed on the aircraft, and then an on-site delegate comes and witnesses the test. So typically there's a FAA DAR installation conformity inspection, followed by a ground test with a EMTEQ or an FAA DER. After that's completed, all of the data and the test reports are sent to the FAA for final review and STC issuance, and then PMA is issued to supply the follow-on kits, the parts manufacturer approval, so that additional kits for remaining aircraft can be shipped with 8130-3. We offer program management for the supplemental type certificate programs. That's a very value-added benefit in that it engages the customer in a very, very low level of detail from the onset of the project, and it really allows that ownership in the program, the development of the solution for that customer. And then we provide in-service support. So once the aircraft has been modified and the STC has been issued and all aircraft are in service, we support any continuing airworthiness or questions that come back from the operator as they evolve in operating with that system. EMTEQ also has the capability of obtaining an FAA and EASA STC in parallel. The benefit is that it's a single project that gets two of the more common regulatory requirements at the same time. And what this provides is a big savings in cost and schedule, primarily in schedule. The benefit with cost is that you're only sending FAA delegates in place of having to send FAA delegates, a DAR and a DER, and then perhaps later sending an EASA compliance verification engineer. You're only sending a DAR and DER for the FAA. And essentially how this project has worked is that the FAA coordinates with the EASA, and essentially EASA honors through the bilateral agreement those findings from the FAA to supply the STC. In terms of schedule, there's a large means of schedule savings when it comes to review time by the Civil Aviation Authority. Typically, We figure EASA takes around approximately up to 12 weeks to review a data package once it's submitted, whereas with the FAA, we can typically do that in about a third of the time if it's needed. And then applicability. Most of the aircraft that are operating out there, either leased or owned, will require either an FAA or an EASA certification. So gaining both of those certifications from the onset of the project is something that will avoid cost and schedule implications later with obtaining an additional validation of the installation that's already been completed. So as I mentioned, EMTEQ has a number of solutions for fans and CPDLC installations. I do want to point out that none of these installations actually certify fans. Essentially what they're doing is installing the systems that are required for a fan type upgrade. So we just took a sample of some of the aircraft that we've worked with here. The Boeing 737 NG series, most popular airplane in the world, the 737. We've worked with both Honeywell and Rockwell systems for the ACARS portion, 2 certified CPDLC with DVRs. We've also got a project in process right now on a 747 for a Honeywell system, Honeywell ACARS system with a Honeywell CVR. And on the 757, we've done several different types of ACARS systems. Some of those were for CPDLC. Some of those can be used as baselines for fans or CPDLC upgrades. This isn't to say that the existing systems certify CPDLC, but they can be used as a baseline. And EMTEQ can also work to develop STC amendments with a custom configuration for an operator's aircraft to certify for CPDLC. So we worked with everything from the Spectralux and the Honeywell systems to the Rockwell systems, and then a variety of the CVR types as well. We're also showing some of the SATCOM systems. Typically for fans upgrades, a lot of operators, if they don't already have an Inmarsat system installed that they're wanting to upgrade, we can use Iridium SATCOM systems. And we hold STCs for those Iridium SATCOM systems that are typically provided by Boeing in a service bulletin, and they essentially parallel the installations that Boeing provides in their service bulletin at a little bit lower cost and quite a bit shorter lead time. So aside from the 757, we've also done a lot of the same systems on the 767, and some of these were used for both CPDLC and fan type upgrades. So they install the required interfaces. In the case of CPDLC, they activate the required interfaces, and they essentially get your aircraft ready for a fans upgrade or for CPDLC operation. And with that, we'd just like to open up the floor to any questions. I believe we did receive 2 questions while we've been presenting, so I'll just read the questions. One of the questions that came through is if there's an exemption for the 737 Classic. Unfortunately, I'm not able to answer that question, but I do believe that is one of the considerations is for the 737 Classics to receive an exemption. I believe it's EASA EC29/2009 that provides a list of those exemptions. And if there's any questions on that, if you'd like to send us an email, our email address is both Jokey and I are on this slide that you're currently seeing. We might be able to research and give you some feedback on that. But we have provided proposals for 737 Classic upgrades for CPDLC for some of the operators that still see an operational benefit to installing the system. The second question that was presented was what SATCOM systems are currently compliant for CPDLC and FANS 1A. When it comes to FANS 1A, specifically in the context of Boeing, Boeing requires aircraft equipment interoperability tested systems, AEIT, for those systems that are going in the airplane to support a service bulletin. As far as SATCOM systems are concerned, on the Iridium side, there's essentially one part number for Boeing aircraft for Iridium SATCOM from ICG, International Communications Group. There's a specific unit that they do use, which is what EMTEQ currently holds FAA STCs on for the 757 and the 767. I'm sorry, the 757 is actually in process right now. It's being updated to add that unit. The 767 is an existing STC, though. Inmarsat systems, those vary, and what we like to work with operators and to tell them if they're doing a FANS upgrade is that they should also seek some responses and seek some input from Boeing. Obviously, Boeing has access to some additional data that EMTEQ does not have access to, since they are the manufacturer of the aircraft, and they hold some of the other service bulletins that we cannot provide. So they need to seek that additional input from Boeing to determine what systems they do have or may require. And perhaps on the other side of getting feedback for the service bulletins, and to contact an STC holder or an STC design organization like EMTEQ to get a quote. Because as I pointed out, we do believe that the STCs are extremely competitive with the service bulletins and often can provide the same solution for significantly less in terms of price and schedule. I believe we have one more question that just came in. For the exemptions, the question came in, for any exemptions from the rule, will they be able to fly above flight level 285? My understanding is that the exemptions, the aircraft with exemptions, will be able to fly at the normal operating altitude. There won't be necessarily restrictions on those exempted aircraft, from what I understand. However, that's obviously subject to confirmation and subject to change as the CPDLC infrastructure is implemented in the different areas. But the genesis of those exemptions is typically the understanding that those aircraft will be phased out of service or retired really when the system, the overall airspace system with the CPDLC architecture in place, once it gets up and running in full. So really the benefits of CPDLC are not really going to be realized until more or all of the aircraft are equipped for CPDLC operations and all the airspace is equipped as well. That's when you'll start seeing those benefits from the for air traffic management in terms of separation. I don't believe we have any other questions, but I'd just like to thank you all very much for joining us. Again, feel free to contact myself or Jolki. Our email addresses are on this last slide right now, where you can find information on the EMTEQ website. If you've got any additional questions or would like to discuss an opportunity or anything related to this presentation, please contact us. But thank you again for joining us, and I believe that concludes our webinar.
Ladies and gentlemen, that does conclude our live meeting today. Thank you so much for joining. You may now disconnect.